Okay, kiddos, we're going to get into applying some of what we've been learning. We're going to use linear programming. It's used in farming and in the business world to maximize, well, definitely profits. Anyway, many life problems involve the process called optimization, uh, finding the minimums and maximum values for something. For example, a company may want to maximize profits right there. We will learn to find minimums and maximums using a process called right here, linear programming. Linear programming consists of a system of constraints, a system of linear inequalities, and an objective function. We'll explain what the objective function is in a little bit. But the constraints are your lines over here, your inequalities that you're graphing, and then you can construct this feasible region. So the constraints are your inequalities, basically. Solving a linear programming problem, finding the minimums and maximums of a value objective function. Anyway, you're going to graph the constraints. Well, basically, that's over here. You're going to graph the constraints and find that feasible region. These are your constraints right here. Okay, they're all inequalities. Find the vertices of the constraints. Okay, right here. The corners, basically, of your constraints. And then finally, evaluate the objective quantity at each vertex. So the least of these values is called the minimum, the greatest is called the maximum. You're going to find that we're going to be working with something like this. F of x comma y. Okay, let's say it equals 2x plus 3y. This is what I call, they talk about maximums and minimums here. I call this the minimum maximum function. That's what I call it. But the book calls it, and you'll hear it called objective function. Okay, the objective function. It's basically this. Now notice it's not inequality, so you're not going to graph it. Some kids mix it up with the constraints. The constraints are all inequalities here. What you do is you take your vertices and plug them in. This vertex here is 1, 2, 3. Looks like it is 3, 2. So I would say plug in 3, 2 into your minimum maximum function. It's 2x. Well, there's my x value, 3, so it'd be 2 times 3 plus 3 times y. Well, y is 2, so it's 3 times 2. Well, this is 6 plus 6, so this is equal to 12. When you plug in that point, you get 12. That might be the minimum, might be the maximum. I don't know. I'd have to evaluate the other vertices there. So here we go. Here's our objective function. We're not going to graph that. We are, however, going to graph our constraints. I can't make it any bigger. We'll leave it like that then. First constraint here is x is greater than or equal to 0. If you're working with x, one variable, this is a vertical line. You graph your x-intercept. My x-intercept here is 1. And I'm going to draw a line right through that. Let's just go with this one right here. And there it is. It says x is greater than or equal to 1. Well, 0 is not greater than or equal to 1, so I definitely am going to be shading this side of that line. Y now, if you're working with a y, that is a horizontal. It's going to be a horizontal line. Y equals 0. Well, there's my y-intercept. And it's a line. Get a line here. Straight across like that. And this one, greater than 0, well, I'm going to go up. So I'm going to put a little arrow up here. So it's going to be in this area up here in the right-hand corner somewhere. Graphing this last line, I'm just going to solve it for y because it'll be quicker and easier. Y is less than or equal to subtracting 2x from both sides. Or you could use your x and y-intercepts, that's fine. My y-intercept is 6. My slope is negative 2, so down 2 over 1. There's one vertice, down 2 over 1, down 2 over 1, and there's my other vertice. Throwing a line through this. See if I can get it just right. There we go. And I'm going to shade towards 0, 0, I'm guessing, because I'm assuming this is my feasible region right here. 0, 0, so 0 plus 0 is less than or equal to 6. That's my checkpoint. And yes, 0 is less than 6, so I shade towards 0, 0. Okay. Next thing we do is we find the vertices. Here's 1, here's 1, and here's 1. So my 3 vertices are 0, 1. I'm sorry. 1, 0. 1, 4. And 3, 0. Now, once we find our vertices, we plug them into this objective function. I call it the minimum maximum function because that's really what you're looking for. We're going to take f of x, comma y, which equals 3x plus y, and plug these 3 vertices in there. The first one, f of 1, 0, equals 3 times 1 for the x plus 0 for the y. It's pretty easy. 3 times 1 is 3 plus 0 is 3. That has a value of 3. F of, let's plug this other one in, 1, 4. So it's going to be 3 times 1 plus 4 for the y. 3 times 1 is 3 plus 4. This is going to give me 7. Finally, my last one here, I'll put it in red so we can see it. F of 3, 0. So we got 3 times 3 for the x plus 0 for the y. That's going to give me 9. Now I can see this. My maximum value here is going to be 9. My minimum, smaller value, is going to be 3. So the minimum of this particular function is 3 and the maximum is 9, according to this linear programming problem. Good, and that's pretty much it. If you can do that, you'll be fine. We're going to get into some word problems that are a little bit harder, but I want you to practice this. I want you to graph this one on your own. The vertices I came up with were 2, 0, -2, -4, and 2, 8. 2, 8 gave me a minimum of -20. -2, -4 gave me a maximum of 8. And I just got 4 for 2, 0. You should be able to graph these. The only one I want to look at is this one right here. Because when you find your vertices, you're going to get fractions. So what I would do is put it in slope-intercept form. You have to be careful. 3x minus y is, I'm just going to say equal to -2 for right now. I'm just going to graph the line. Subtracting 3x from both sides, I get -y equals -3x minus 2. And then dividing everything by -1, I get y equals 3x plus 2. Now when you check to see which side you shade, go back into the original inequality. It's the same line, but when you shade right or left or below or above it, use right here, the original inequality. So 2, and then my slope is 3 up 3 over 1, down 3, back 1. So it should go in here somewhere like this. And then when you check 0, 0 again, okay, make sure you plug it into the original. But you have your information here. I want to go on to the next problem where we actually have to set up and define some variables. Here's the steps. It says to define variables, write the system of inequalities. That's the main thing right here. And then some people struggle with this one. Steps for writing the minimum maximum function basically, and I'm going to go over that in this next problem. And we'll cover a few in class tomorrow. The exception is for a veterinarian. One of Dolores Alvarez's tasks is to schedule appointments. She allots 20 minutes for a routine office visit and 40 minutes for a surgery. The veterinarian can do no more than 6 surgeries per day. The office has 7 hours of available appointments. So right there's some constraints. Only 7 hours for appointments, and you can only do 6 surgeries. An office visit will cost $55 at most, and surgeries cost $125 at most. As soon as they get into the money part of it, that's when you're going to be talking about your function, your minimum maximum function. How can she maximize the income for the day? Everything above what I underlined, I'm sorry, up in this area right here, you're developing your constraints. But first we got to come up with variables. Well, they're talking about surgeries and office visits. So number of office visits. Oops. We'll call that X. Okay. Number of surgeries. We'll call that Y. Now the first thing we've got to do is this. You're not going to have negative office visits or negative surgeries. So X is greater than or equal to 0. And we're also going to say Y is greater than or equal to 0. Okay, so it's going to be in the first quadrant. The veterinarian can do no more than 6 surgeries per day. So Y also has to be less than or equal to 6. That's another constraint. The surgeries and the office visits are in minutes. So I'm going to change 7 hours to minutes, and that is going to be 420 minutes of time that we can do these office visits and surgeries. So basically it's this. It's 20 minutes for an office visit, so 20 times X, plus 40 minutes for a surgery. It says right here, 40 times Y. X is the number of office visits, Y is the number of surgeries. And this all has to be less than or equal to 420. Okay, so there's our constraints. Okay, now it says to graph the system. Okay, so we're going to graph the system here. First of all, X is a vertical line, remember. And so if I say my x-intercept is 0, I'm talking about right here. And it's greater than this. X is a vertical line. Y are horizontal lines. Y is greater than 0. That means we can't have any negative surgery, so I'm just going to put a line right here. That's Y is greater than or equal to 0. This line is X is greater than or equal to 0. And we also have this one right here. Y is less than or equal to 6. No more than 6 surgeries. 1, 2, 3, 4, 5, 6. Right through here. So it's less than or equal to 6, so it's got to go below it. Greater than or equal to 0 for Y, got to go above it. So it's going to be in this tube right here, basically somewhere. I'll graph this last line right here in green. Well, if you use the cover-up method, just plug in 0 for Y. You're going to get 20x. Let's just say equals 420 for a minute. And you divide 20 into that. You're going to get 21. So my x-intercept equals 21. So I'm going to go over here. 5, 10, 15, 20. Right here. And that's going to be a vertex then. My y-intercept, well, I'm going to plug 0 in for x, and that's going to give me 40y. So less than or equal to 420. Well, it goes in there 10.5 times. Say equals. So my y-intercept is 10.5. Oh, we got 1, 2, 3, 10, right about here. Now, if I took this equation and put it in slope-intercept form and found my slope, okay, it would be 20x plus 40y equals, I'm going to say 420 for right now. Subtracting 20, I'm going to get 40y equals negative 20x plus 420. Dividing everything by 40. I'm going to get right here, y equals negative 1/2 x plus 10.5. Saying Picard, we already got a graph, just got to draw a line through it. I want the slope, negative 1/2. So I could go down 1 over 1, 2 right here, or I could go up 1 and back 1, 2. Up 1 and back 1, 2. Up 1 and back 1, 2. And I'm going to keep doing this until I get to this point right here. I really want to find that vertice. That vertice right there looks like it's 9, 6. I'm going to draw a line through this. There it is. And if you plug 0, 0 into this function, you're going to get 0 plus 0 is less than or equal to 420. And that's true. So basically, my feasible region is below. It's everything inside this area right here. And you know what? We will finish this problem tomorrow. We're kind of running out of time. And, well, I guess we'll see you tomorrow. Actually, what I'd like you to do is find the vertices. You can see that what the vertices are going to be right here. Here's 0, 0 down in the corner, 0, 6, 9, 6, and then 21, 0. See if you can come up with the minimum maximum function, plug those vertices in, and see if you can find the max or min, and we'll take it from there tomorrow. But we'll see if you can do that, and good luck.